Okay, today we're talking about simplifying and factoring trigonometric expressions. So here we've got the command to factor. So we're going to factor all of these expressions just like we did from Algebra 2 and Algebra 1. We can factor them algebraically. We want to look for patterns that were similar to those that we did in the past, such as Algebra 2 or Algebra 1. This right here looks an awful lot like x squared minus 1, which is the difference of two squares. So this becomes x plus 1, this becomes x minus 1. So taking this algebraic principle, I can now do the secant of theta minus 1 times the secant of theta plus 1, and it is factored. Okay, the next one right here looks an awful lot like 4 times x squared plus x. So I'm going to factor out an x, and that leaves me with 4x plus 1. So here I'm going to factor out a tangent, so the tangent of theta, and I'm left with 4 tangent of theta plus 1. And there's nothing else to factor there. The next one is a lot like 1 minus x squared, which again is the difference of two squares, 1 plus x, 1 minus x. So I use that same principle here, 1 minus cosine of theta, 1 plus cosine of theta. For the next one, this one gets a little bit more complicated, especially when it comes to factoring the trinomials. So this is like 2x squared minus 7x plus 6. And most of you, I'm not sure which methods you guys used to factor. I use what's called bottoms up. Okay, and that basically says I multiply the first term times the last term, and I get a positive 12. That's my product. And then I find the factors that add to give me negative 7. So that's going to be a negative 3 and a negative 4. And each of those factors I go back and I divide by the leader, which is this 2. And then, of course, I reduce those if they can be reduced. Negative 3 halves cannot be reduced, but negative 4 halves becomes a negative 2 over 1. And this number in the denominator is going to be the coefficient of the x, and so my factors would be a 2x minus 3, and this will be a 1x minus 2. And it works every time. I have not found a moment to which it does not work. So I'm going to use this pattern to rewrite my trigonometric expression. So I have 2 times the cosecant, sorry, that's supposed to be in parentheses together, the cosecant of theta minus 3, and then I have cosecant of theta minus 2. So I just use those, and where there was an x, I just replaced it with cosecant. Okay, so we can factor that way. Right here, this is kind of like an x squared minus a y squared. So we're going to use the difference of two squares. And so that becomes sine of x plus cosine of x and sine of x minus cosine of x. Now, there are other options that we can do when it comes to substitution using the identities. So we can also take sine squared theta and we can replace it with a Pythagorean identity, and likewise we could do the same with cosine squared theta. So we're going to look at some examples to which we can do that as well. Okay, so that's some factoring right there, trigonometric expressions. Okay, now let's talk about substituting these identities. So we can also substitute identities in order to factor the expression. So notice here, I have cosecant squared x minus cotangent minus 3. Well, these are not like terms. So I need to figure out how to change one of those to give me all the same trigonometric terms. Well, I don't have any identities that deal with cotangent to the first power, but I do have some identities that have a cosecant squared, and most all of these will be Pythagorean identities. So I know that 1 plus cotangent squared x is equal to cosecant squared x. So I'm going to substitute this for this expression here. So that's going to be 1 plus cotangent squared x minus cotangent x minus 3. Then I want to put it in standard form. So my squares lead cotangent squared x minus cotangent x, and then combine your numbers to a negative 2. Okay, so algebraically, that's like x squared minus x minus 2. And I can factor that into x minus 2, x plus 1. So this will be cotangent of x plus 2, cotangent of x, sorry, that's a minus 2, plus 1. Okay, the next one, again, I would use a Pythagorean identity. I've got secant squared x plus 3 tangent x plus 1. So I'm going to replace the secant squared. So that's 1 plus tangent squared x is equal to secant squared x. So this is going to replace that. So I have 1 plus tangent squared x plus 3 tangent x plus 1. Okay, then I want to, of course, combine like terms and get it into standard form. Squares lead tangent squared x plus 3 tangent x plus 2. Okay, so that's going to be like an x squared plus a 3x plus 2. And I can factor that into x plus 2, x plus 1. So this will be tangent of x plus 2, tangent of x plus 1. Now I'm showing you the correlation between algebra 2 factoring, and the pre-cal factoring. Okay, one more for today. We've got cotangent squared x minus cosecant x minus 5. So I do know that cotangent and cosecant exist in a Pythagorean identity. 1 plus cotangent squared x is equal to cosecant squared x. But I've got to replace the cotangent here. So I'm going to subtract 1 from both sides. And I get cotangent squared x is equal to cosecant squared x minus 1. And so this right here is going to replace the cotangent squared x. So now I have cosecant squared x minus 1 minus cosecant x minus 5. Combine like terms and put it in standard form. Squares go first. Cosecant squared x minus cosecant x minus 6. Alright, so that's going to be like an x squared minus an x minus a 6. And this would be an x minus 3, x plus 2. So I'll have cosecant x minus 3 cosecant of x plus 2. And there I have factored my trigonometric expressions. So for your homework, I'm going to ask that you work in the book, page 354 to 355, numbers 33 to 54.